Yeah. So I'm Bruce Dello. I've introduced myself to most of you while I've been here. But in case you've spent the entire ACT workshop wondering who is that handsome devil, it's me. Bruce Dello. I work for the Ocean Tracking Network with Angela and Shannon and for John Pye, whom I'm sure many of you have had the unique pleasure of meeting. I think he's online still too. That's, we'll say, good. I'm here today to talk a little bit about Remora. What I'm going to do is give you a little bit of context on it, what it is, where it came from, the impetus for OTN taking control of this fork of it, and molding it into what I'm going to show off today. After that, I'm going to take you through a couple of small case studies, I guess, with two data sets, one relating to Atlantic sturgeon, which we all love. We've heard a lot about sturgeon this week, and it's not going to stop now. And another relating to Nassau grouper, Goliath groupers, sorry. Slightly different grouper. So we'll take you through those two case studies. I'll show you the workflow that you'll use to put your data into Remora and get something out of it. I think I've been budgeted a lot more time than I'm going to need. So we'll have plenty of time for questions. We might all get out of this a little bit early and be able to go have dinner. And this might be too much information, but just in the interests of full disclosure, I started feeling a little ill a couple minutes ago. I'm not sure if it's stress or food poisoning. I don't think it's going to amount to anything, but if I get a kind of haunted look in my eyes, that's why. I don't know if we have any big Stingray fans in the audience, but anything can happen in the next 90 minutes. Okay, let's get started. So, what is Remora off the jump? I have given some of you the truncated explanation so far, but Remora is an R package created by our opposite numbers down in Australia at IMOS, which I think stands for Integrated Marine Observing System. Remora itself stands for Rapid Extraction of Marine Observations from Roving Animals, which they worked really hard. They stretched for that one, but boy, howdy, they got there. It is an R package with two components. The first is a set of functions for matching acoustic detection data to environmental data. That's the last we're going to talk about that because it's not working yet. But if you pull down Remora tonight or tomorrow and you see a bunch of functions that I haven't touched on, it's probably because that's what they're for. So there's a part of the software that we're not going to address today because I haven't done anything with it. The part we're going to be talking about is the suite of quality control functions and functionality. One half of Remora's functionality is taking acoustic telemetry detections and running quality control on them. So not just one test, but a series of 7 tests and an 8th aggregation. You can sort of see down at the bottom. I'm going to start explaining them eventually. But it will run several QC tests on your detections and assign each detection a score from 1 to 4, where 1 is very likely to be real. 1 is very likely to be real, 2 is likely, 3 is unlikely, and then 4 is probably false. Where OTN came into the picture is when IMOS made Remora, they made it to support the methodologies and conclusions of a very specific paper by Xavier Wenner et al. It did that wonderfully, so wonderfully that John got wind of it and he came to me back in the days when all I did was think about playing Quake and being happy. And he said, hey, can we make this work? Can we feed our detections into this? Can we take detections from OTN nodes, put them through Remora, and have the quality control functions work? The answer then was no. Reason being, because they had written it for this very specific purpose, there was a lot of hard coding. There were a lot of assumptions built into it such that it would only work if you were coming to it with detection data from IMOS. So it was very regionally locked, very purpose-built for this one specific need. And so what I've been doing for the last 18 months or so is breaking it open, cutting it up, bolting new parts onto it so that now, today, as you'll see, you can show up with an ocean tracking network detection extract, much like the one you probably have in your home or car, and run it through Remora and get your quality control done on your detections. The goal of this development has been to get to that point, the point where you provide Remora with the detection extract and you get back your detection extract with a set of extra columns to indicate the quality control checks. So that's where we're trying to get to. It's where I think we have got to. With that context, I'm going to go into a couple of case studies, unless there are any questions so far. If there's anything that wasn't cleared up, that doesn't have to do with functionality, just has to do with the context, I'm happy to field those questions now. But it seems like everybody's good. Okay, yeah, just checking. So I'm gonna, as I go through this, I'll outline some of the caveats to do with the detection data that you have to supply, the results you're going to get back. The big caveat is that Remora is right now in what I like to think of as its open beta for all the gamers in the audience, which is to say, I think it's in a decent place, but I'm not a scientist. I don't know about fish. I certainly don't know more about fish than you guys do. I'm not even convinced they're real. I've never seen one. So this, after today, my hope is that we can get Remora into the hands of people who actually have the detections, and you can start working through it and finding bugs, telling me about the bugs, and about the fish, because again, I don't know about those. And we'll together build it out from here. So let's get started on some code. I'll scroll up to show you, there's a whole lot of libraries that I have to import, a whole lot of packages I have to make sure are here. I haven't fully ironed out the setup step for Remora yet. That's one of the caveats. If you're going to pull down Remora and work with it, which you should, there will be a couple of packages you will have to make sure you've got. Remora does not, as it stands, pull down everything that it needs. But I will be here tomorrow at the study hall, so if you start in on Remora right away, if you get really excited, you can ask me to help, and I will. Yeah, it'll be great. But moving on to the part we actually have to run code for, the first thing that we are going to do, yeah, okay. We have to get a raster of the land masses of the world. This is required for some of the QC tests. Remora originally came bundled with a raster representing Australia, because again, it was locked in onto Australia. We wanted to break that out and make it global, so of course we need a map of the world. The raster we're using is natural Earth 50-meter resolution. It works fine for us, but the nature of this code is such that if you showed up with your own favorite raster of world land masses, you could use that too, and it, I think, would work. So let's run that. Okay, no problems. I feel pretty confident in this code because I ran it a couple times yesterday and it worked fine. So I'm sure that today it will break. But moving on, the next variable we have to define that we are going to pass into Remora is this tests vector. It's a character vector containing the names of the tests that you want to run. For the purposes of this demo, in both cases, I'm going to run all the tests just to show off, for the sake of completeness, all that Remora can do. But I have built it such that you can turn certain tests on and off by, in this case, you can comment out these lines, or if you were writing this from scratch, you could not write the tests you didn't want to do. So if you don't want to do your velocity or distance tests, you don't want to do the detection distribution test, you don't have to. But I am going to do all of them to demonstrate that they can all be done. To briefly take you through these tests, these are the ones that came with Remora that they had built in to support their paper. I will take you through them. I think I'm going to stand up to do that. No, I'm going to sit down. It's easier to read. False alarm, staying seated. So the first one is FDA, false detection algorithm. Remora came bundled with its own using time differences. We re-implemented, we added a different false detection algorithm that uses the Pincock filter as implemented in the GLaTOS library. So by default, if you're working on, no, not by default, you can pass in which one you want to use. Apologies, I misspoke there. So yeah, is the detection likely to be false based on the Pincock algorithm or Remora's time diff algorithm? Velocity QC, did the fish travel unrealistically far? Put a pin in unrealistically. Distance QC, did the fish, velocity is, did it travel unrealistically fast? Distance is, did it travel unrealistically far? Between two detections. Detection distribution, was it detected outside its known home range? Put a pin in known home range as well. Distance release, was it detected unrealistically far from the release location? Release date, was the fish detected before the release date? And release location, was the release location within the home range or within 500 kilometers of the first detection? So those are the QC tests that it will run. Detection QC, the last one, aggregates all of the above tests and returns a value between 1 and 4, which I described earlier. The way it does that, I wrote in, it used to be based purely on the number of tests. It would assume that you were running all 7, but now that you can turn tests on and off, it's based on the percentage of tests that passed or failed. To circle back on the 2 pins that I put in there, when I say unrealistically fast, unrealistically far, eagle-eared viewers will have noted what is unrealistic. At this point, I know I have parameterized some of these and exposed them to the user. The values for what constituted unrealistic were, again, hard-coded in the original version of Remora because they were dealing with a subset of species in a specific area. They could be a little more firm with what they considered unrealistic. Obviously, if we're applying this data to fish that migrate transatlantically or migrate up the coast, unrealistically fast or far could be a different thing. So some of these I have made into parameters that can be exposed to you to decide what makes sense for your study species. I just forget which ones I've done and which ones I have yet to do. But it's high on my priority list now that I've got it all working generally. So don't worry. I know it's as recently as a couple of weeks ago, this code wasn't working as well as it works now. So it was a bit of a lift. Now I can go back and clean up some of the rough edges that I had to deprioritize in the name of having something worth showing off. The second pin that we put in, known home range, you may have also wondered, how do we know what the home range is? Where do we get that information? Originally, Remora could access the Atlas of Living Australia and CAAB, the codes for Australian aquatic biota. Those were two resources on which they could draw to get expert distributions. I called them shapefiles representing species home ranges. Those are not necessarily applicable to all of us because the whole world is not Australia. That's one of the things that I learned in the course of developing this code. Australia, not the whole world. Easy mistake to make. So the first thing that we have to do is get ourselves a spatial object representing our species home range. I'm going to show you how to do that with code that I put in Remora. I didn't write the code. The code was written mostly by Steve Formel of Obis USA. It's very, very cool. I will explain it when I start running it because it takes a little while to run. Like I said, our first, before I continue, are there any questions about the QC tests as written there? What are your questions? Anything I can clarify? We're feeling good? Chat's okay? Excellent. Great. Oh, one other thing before we move off the tests vector subject. In Angela and Shannon's talks, they mentioned that during the OTN data ingestion process, we do some of our own QC. In this case, that includes definitely the release date test, and I believe the release location test. I'm still going to include them, but they will always pass. So I have included a catch in the data aggregation step, the QC aggregation step, rather. So that if you are working with an OTN file, those tests can still be run, but they will not be counted towards your detection's final score. We do need them. Some other Remora functions that are very useful depend on those being there. But if you're working with OTN detection, that QC step will have already happened. So moving on, we are going to start by telling Remora what file we wanted to look at. In this case, we have we have a detection extract from UGA ACI 2017, generously on loan from Joy. This is Atlantic sturgeon data, and I'm going to create that variable. Did that get made? Yeah, okay, good. The reason that we are creating it in this way, the list with the internal det there, rather than just passing the raw file name, is because we are working towards being able to supply a detection extract, a valid receiver metadata file, and a valid tag metadata file, and have all of those be used in QC. If you don't have those, though, we spent a lot of time getting it to the point where you can show up with just the detection extract, and relevant receiver and tag metadata is derived from that. So the information that would otherwise come from the receiver and tag metadata files, in some cases it can be directly inferred. In other cases, we can make some reasonable guesses about it. I will be able to talk more about those if you have questions, but I'm getting to the point of being able to run this chunk of code from Steve Formel. I would like to get it started because, yeah, the code is a little bit the time crunch part of this. So we are going to define our scientific name, Accipenser oxyrhynchus, Atlantic sturgeon. We love sturgeon. Everybody loves a sturgeon. What's not to like? We share a common ancestor. They haven't meaningfully evolved in 95 million years. They're big, they're cute, we love them. So now we are running get occurrence. We pass in the scientific name. What this does, like I said, this is a nice piece of code written by Steve Formel, Obis USA. This function will get occurrence data for your species from Obis and from GBIF. It will knit them together into one object, which you can then use in further steps of Remora. So this is our first step in creating that species home range. And yeah, this line takes just under a minute to run. When we do it for Goliath groupers a little while from now, it'll take a little longer because it's a bigger data set. While that's finishing up, what are your questions about the process so far, or about anything I've brought up to date? Nothing? Cool. All right. I assume that means everybody understands perfectly. That laughter was uncomfortably nervous. Geez, people, you got me here. Like I'll answer your questions. Okay, so that shouldn't be too big. I think we can look at that. Let's briefly look at sturgeon occurrence. So it's a small object. You can see that it's got your occurrence ID, which, oh, look at that, OTN MPD. Hey, that's us. That's me. I did that. I didn't do that. I don't. But I mean, OTN is us. We publish data to Obis. So a bunch of our occurrence IDs are just going to be there. Other than that, decimal latitude, decimal longitude, and this column here, source, will tell you Obis or GBIF. Again, that's part of Steve Formel's code, and I like it, so I kept it. But yeah, that's what we're looking at, just latitude, longitude, points. The next step of the process, this is based on work by Jessica Castellanos, a student who we had working on this to help us find a reliable way of getting our hands on shapefiles. And I'm going to set this running because it takes a minute too. This will take that occurrence data and create an alpha hull around the points. And my understanding of what an alpha hull is, and people more experienced can set me straight if I'm wrong, but I think it's a fancy way of saying it's the sort of minimal shape that encloses all of the points. Under the hood here, we are using a library called VoluModel, which in broad strokes is for creating 3D volumetric models of species home ranges. But they have a quite nice function for doing exactly what we were doing, taking a set of latitude and longitude points and creating a shape around them. And yeah, it takes a minute. So once again, what are your questions? If indeed there are any questions.
How do you know sturgeon are cute if you've never seen a fish?
Yeah, you got me. I was telling a joke. It was just a bit I was doing. I was trying to do a funny. I'm gonna do a couple today.
I've never seen one either.
No, I like sturgeon. I think they're great. I've been fascinated by them ever since I read about the Loch Ness Monster as a child, and some people were like, "What if it's a sturgeon that got into Loch Ness?" And I was like, "What's a sturgeon?" And it turns out it's this cool, huge, prehistoric fish with the mustache. It's so cool. I love them. Anyway, code's done running. So I'm gonna, oh yeah, that should be fine. It's only me that can't see it. Minimize that. There we go. Just to show you what we've created, we can plot sturgeon polygon, and of course it's quite tiny there. But you can sort of see, it'll be clearer when I plot all of our results. But this is sort of a verification step to make sure we got something that actually makes sense. And you can see the eastern seaboard of the United States and the little bit of Florida there, and also some mystery dots over here. What are those? Oh, that's a fun secret for later. So we have created now our shape representing our species home range. In original Remora, you wouldn't have had to do this. This is a step that is necessary because we don't have access to the ALA and the CAAB to get species home range files. What we're going to do now is what you would have to do if you were using original Remora. But now we've got all the variables that we can pass in, and so it will run if I've been good and I'm lucky. So it will take a little while to run. I'm not going to be able to explain all of the messages that get printed out here, in part because there's a lot of them and not all of them are super interesting. But I will touch on this one, deriving receiver data frame. That's that's coming out of the code that we wrote to derive receiver and tag metadata from a detection extract. Mike alluded to this earlier, but in order to get Remora to the point where it would ingest OTN data, we have actually written an entire different second package that translates between institutional formats. So we didn't do a whole lot of hacking up under the hood to make Remora understand OTN files. We went the other way around and we wrote a package to take an OTN file and chop it up, change all the column headers, and make it look like an IMOS file. So that Remora will look at it and say, I know what that is, and operate on it cleanly. That package is, we're working on expanding it so that we can translate between more than just those two. Oh boy, here we go. Yeah, this is object text vector not found. Okay, nope, that's easy. I just didn't define this variable. Whew. That's the wrong line of code. This one should be fine. It should work this time. What was I saying? Right, I was talking about our other package. Yeah, we want to expand that package so that it can translate between more than just OTN and IMOS. The idea being that analysis packages will be written that can be useful, but like Remora, they may be written for a specific region, for a specific institution that has its own way of formatting its data, its own column headers, its own expectations. We want to get this translation package working such that you can take your data from an OTN node and translate it into any institutional format you might need, such that you have broader access to all of the available analysis packages. And since we've got about 5.5 minutes before this code is finished running, like I said, it's kind of time intensive. I'll tell you that package that I'm working on is called surimi, which is a really funny name if you eat a lot of sushi and know what surimi is. If you get sushi and it's got that imitation crab on it, that's what surimi is. It's whitefish that's been chopped up and flavored so that it seems like crab. And that's what we're doing to your data when it goes into surimi. We're cutting it up and we're messing with it until it looks like something else. So as you can see, that joke is extremely funny. Anyway. What are your questions? I see, okay, yeah, we got one, finally. What's up?
Find your shapefile of land world. Then I see printing out that there's maybe some clipping of the home range polygon to that, and a lot of us, me included, work in very detailed, very narrow shore areas. Is functionally using that shapefile or polygon of the shoreline and the earth to do any of this QC? And by that I mean, is it worthwhile to feed it the most detailed for your area? Will that affect anything, or is that not functionally, it's more just for display?
That's a great question. To reiterate for the chat, the question came up that we're using a raster of the coastlines of the entire world, but a lot of people who are going to end up using this are working in smaller, more tightly defined regions. And so the ask was, is it using that for any QC step? And would it be would it make any difference to feed in the highest resolution data that you've got? So answer to the first part of that, yes, it does get used in some of the QC steps, principally the ones to do with distance. The other answer to that piece is I want to get it to the point where you don't have to pass in the whole world. You can pass in your own cropped version of it. Specifically, I wanted to derive the study area from the detection extract and automatically crop it to that. In which case, yeah, having a very, very, very high resolution file will possibly be a good asset to have. But yeah, the exact process of ingesting a raster of the world is something I'm still working on. So I'm going to keep your question in mind as I go forward on that. For the immediate near-term future, I think the version we've got with the 50-meter resolution is okay. But that does lead me into another point that I wanted to touch on, which is that I am not a fish scientist. I've got Remora to the point where it runs and produces some output that makes visually intuitive sense to my eyes and brain. But I want to get this into your hands so that you can put your data through it and gauge how much sense it makes with your better expertise. This gets back into what we were talking about day one, how there's no way to strip the human element out of the QC process. At the end of the day, swallowed a bug. At the end of the day, the QC, the most important step of the QC process is the researcher with their experience and their intuition and their gut looking at the data and saying, that makes sense, or that doesn't make sense. So to a certain extent, the effect that supplying a really high resolution coastline file is going to have is yet to be determined, and it's yet to be determined by all of us together as a group. Oh, we're almost done. Other questions from Joy? Yes, what's up?
What happens if you have a multi-species project?
Good question. At this stage of the game, I can't tell you how Remora will react if you do that. Original Remora was able to handle a multi-species detection. In the process of getting it to this point, I have only tested it with single species detection files. So being able to work on multi-species detections is something I want to build towards and verify because it's part of that original feature set. So I know it's possible with the underlying code. But as it stands, I don't have a great answer for how Remora will react if you try to do that with a multi-species OTN detection extract. Yeah, I mean, sure, you can do that. I won't stop you. Yeah, it's like I said, we're in the exciting phase of discovering how broken this thing is. So yeah, let's do it. Let's find out.
If these stops, when it gets brought in, if you did have a project, basically writing code, split it out by pick out what the species name is basically from that file, and then run this separately, and then it joins them all back together at the end, or is it easier to figure out how they can work with multiple polygons?
No, that was my first thought. When you had asked the question was probably you could sort the file, you could break it up into multiple data frames, you could process each one individually and then return them in as a series of objects. That's what original Remora did. So I think that's fine. I think that's a perfectly useful way to do it, unless you are comparing between species, in which case, yeah, there would have to be some after the fact merging. But yeah, it remains to be seen specifically how I'm going to implement that, because I am going to implement it. No one can stop me. So, further questions before we get back onto the code? No, nothing in chat? Wow. Okay. Let me see. I'm a little, I should have thought to check this out. Sorry? Yeah, I figured it was only a matter of time until John started heckling me. Don't laugh at anything he says. You'll distract me, and encourage him, which you shouldn't do. I'm just going to quickly see if, no, you know what? I want to get through all my code. The one thing I didn't think to do, right, was to view the object that comes out of Remora, because I didn't think I was going to do it, so I didn't worry about it. And I almost had the thought of, oh, I'll just do a view right now. We'll see if it works. But those objects can be kind of big, and they don't always play nice with our studio. And if our studio crashes in the middle of this, I will cry. So I'm not going to do that just yet. But at the end of this, after I've run all the code that I want to run, we'll view one of those objects, and we'll see. I'll show you what it looks like. Essentially, it's a nested tibble. What it returns is 2 columns. One column is your tag names, and the other is the QC associated with the detections on that tag. So it breaks out your QC on a tag by tag basis. So you might think that I don't have anything to show you. That's not true. I actually do have something extremely cool to show you. Ian Johnson wrote this plot QC file, or function rather. And when you run that, we pass it in the tag QC, the home range polygon that we've created, and the data format. There are a bunch of, you'll see a similar one up here in Run QC. One of the asks from IMOS when we started hacking this up is there is a community of people using Remora down in Australia. And so they wanted us to make sure that they could continue to do that with whatever we ultimately built. So there are a whole lot of instances where you'll supply the data format, and that will get passed through the code so that it knows, hey, run the original IMOS version that we haven't touched or done anything with, versus run the crazy OTN version that's nuts. But okay, so we run the plot QC step. This is some debug that I put out. And I'm going to pull this up so that we can see it. So this is the output from Remora's plot QC. This is what you ultimately get for all your trouble. You get this nice interactive plot that has your species home range superimposed on it, and it's got your dots in 4 colors representing how likely those detections are to be valid. So if we zoom in, these yellow blorbs are the release locations, and everything else is a cluster of detections. So we can click on those. They have these quite in-depth tooltips, which they don't tell you which tests passed or failed. That's something that I might circle back on and put in there. But they do tell you what your station name receiver, or what your station name is, your latitude, your longitude, how many detections there were, how many different tags were there, and whether or not it's likely to be valid. We can change the background as well. You've got your satellite, got bathymetry, and we can toggle on and off various layers here. So there's your species distribution. I'll zoom out so that it's clearer. We can toggle that on and off. We can drop the detections by validity, and we can turn off our releases, our deployment locations as well, to just look at our data. So right off the jump, we can inspect our data and see if our QC results make sense. You'll note that we've got one invalid detection way up here in the Bay of Fundy. Again, I don't know, but to me that makes a certain amount of sense. Most of our detections are way down here along the Atlanta, Florida coastline. And then we've just got this one weird outlier up here. One of the strengths of Remora is that it doesn't throw data out. There are some rows that it wasn't able to process. I'm still working on that. That's a thing that I'm hammering out to figure out what the problems are there. But when you get to this stage, it hasn't filtered anything out. It's showing you the detections alongside how valid they are. So if you're the person who put out all these tags and you're looking at that and you think, no, that makes sense, you have that option to go and investigate that. Additionally, nothing gets marked invalid just because it failed one test. So this isn't invalid because it only failed the distance test, maybe. To get to that stage where it's being flagged as definitely invalid, I think well, I can check, can't I? I've got the code right here. But I won't dig into it too much just yet. I'll stick with what I know, and then I'll get into the weird stuff at the end if we have the time. But I think it has to fail something like 75% of the tests that we've run in order to get flagged as invalid. So that's got some stuff going on with it. Likewise, down here, we've got the other end of the spectrum where we can see that there are a bunch of detections that are outside the species home range because we don't have enough resolution on our home range to get deep into these river areas. But the detections there are still getting marked overwhelmingly as valid or likely valid, because just because they're outside of the species home range doesn't mean that they didn't pass all the other tests. And if you're passing 6 out of the 7 tests, that's still probably a pretty likely detection. So again, we have our output making a certain amount of intuitive sense, which is nice. Like to see that. I also promised you a special surprise for later, that the little outlier dealy boppers when I plotted the sturgeon polygon, those are actually over here off of Norway, Sweden, and Denmark, which this is a fun fact that John dug up while I was demoing this. That includes the historical range of the Atlantic sturgeon. They weren't there for a long time, but they're being reintroduced to their historical European manners, I assume. Fjords? I don't know what they have. That is in aid of a useful caveat, though, is that GBIF, I think, it includes historical observation data. So you may get outliers way out there in places you're not expecting, because that was a location that the fish used to be and is no longer. Fingers crossed that doesn't happen too much in the near future. But hey, that's why we're all here, right? So an interesting caveat, I think. So that is the entire Remora workflow as it stands. 4 functions. They each take a little while to run. You could not do the 4th if you didn't want to plot your output. I have worked kind of hard to boil it down to 3 lines that you can run even if you are only passing familiar with R. So you show up with your detection extract, use your scientific name, get your species home range shapefile, and you run it through Remora, and you get your QC. I've got one other case study to show you, this one of Goliath groupers. Before I get to that, what are your questions? like I said, I've shown you the sum total of the workflow as it stands, and I'm happy to field any uncertainties that you may have.
I don't know if you want to do it now, but we can dive into one of those invalids that are well within the valid.
We can try to find that. Let's see here. Oh, you know, Remora does have this. Where's my, I mean, at this point, if I don't get into the grouper one, that's fine. There are some interesting little extra hitches to do with stuff there that are useful to look at. But if we don't see it, it's not the end of the world. So let me take a look at, where is it? Where is it? There is, or there should be, qcsummary.csv. Yes. View file. Oh yeah, okay, so it's a little ugly. Fine. Import data set. Yeah, all right. So I haven't looked at the QC summary files much. So yeah, okay. Let's take a look at one of those. That's not what I wanted to see. Viewer. All right, let's find one of the really invalid looking ones. Okay. Let's take a look at this one. Okay, station name. What are our transmitter IDs? A69, 1601, 43324. 43324. Okay. So this row 49. Let's see what we get here. Invalid deployment location detections outside species range are NA for most of those. Tracking duration, invalid velocity. Okay, this is, it's interesting. What do we got here? Apologies if this is not terribly interesting. Like I said, the QC summary file is one of the things that I deprioritized a little bit while I was working on getting the code to the point where it would run. So I'm discovering this a little bit at the same time you are, seeing what's bundled up in here. I'm seeing that we've got total detections, no detections before deployment ever, so that's great. And then we've got valid detections. So I'm going to narrow this. Oh, whoops. All right, that's not. Each line is a transmitter ID. Although each point over here is a, I believe is a receiver. I'm sorry, I'm having a hard time digging through this. We've got a bunch with 0 valid detections though. Okay, so let's see here. Detections before deployment. There are a fair few that didn't get the QC run at all. In cases where the total detections are 1, I believe we don't run QC on those because if there's just the single detection, we can't do anything with it. I think those are the releases. But yeah, we can't do any of the comparison. Let's see here. 14,714, 4116. I'm trying to find one here that has a reasonable discrepancy between the total detections and the total valid detections. I'm not seeing a huge amount of, let's try something different. Let's go to that one way up north. Because I think that's just the, yeah, okay. A69, 1601, 433.28. You're all being real sports for putting up with me while I sort this out. and see if I can. Processing this output was not a thing I did much of, so it's interesting. Okay, so this is interesting actually. So that row A69 1601 43328 has 320 valid detections, or total detections rather, and 319 valid detections. So that one way up there in the north is the only one that didn't track. So that's interesting. Let me pull up, let me just see, view OTN test tag QC. Please don't break our studio. It's gonna take a minute. Yeah, it's it's going to take a minute to run. Oh yeah, it has 100% crashed our studio. You'll love to see it. And I just remembered too the exciting piece that I had worked out that bolts the QC information back onto the detection extract. So I could have just opened that and looked for the tag in there, and that would have been the smart thing. Oh, here, oh, yeah, okay, it's gone now. We're fine. It can't hurt me. Yeah, it didn't like that. That's fine. Sorry, I'm not used to navigating with so much extra junk on my screen. All right, so where is my rolled output? Here we go. You don't need to retrieve that preview data, that's fine. So interesting point here. What do I mean by rolled output? Again, it was supposed to be clever because it's taking your original detection extract and the quality control information and bundling them back up together, because it's like it's part of surimi, right? So it's supposed to be a roll up like a sushi roll. Anyway. Let's see. Sorry?
You had Indian food, that's why the jokes aren't working.
Yeah, I also don't know how good I feel. So if I'm having a hard time mustering the energy for comedy. It's yeah, I'm sorry, it is a little difficult to navigate these on the on a screen this small. Can I get back to you on this? No, it's fine. It's, you know what? I'm glad that you did ask that question and did kind of put me on the spot, because like I said, the piece of this, the output of this is something that I have neglected a little bit. You know, I get as far as plot QC, I see the picture, I think, okay, good, fine, this all makes sense. And I didn't, you know, this was a couple of weeks ago, so there hasn't been a whole lot of turnaround time. But I got to that point and I didn't think like, you know, I just assumed, oh, the researcher is going to have their data right there in front of them. They're going to know what to do. It's fine. They'll be able to just, they'll know. But like, yeah, it actually is kind of tough to, if you see that data in the plot and you line it up and you say, that doesn't make any sense. Like, it is actually a little tricky to figure out where to go to drill into that. That is extremely useful to know. Because if you can't, you know, if you can't easily go back to your data with the insights you've gleaned from your quality control, like, what's the point? What are we doing here? So no, I'm actually, that was a good question, and a useful thing for me to know and to be able to take home. So I do appreciate that. And I just, yeah, I wish I could have dug in there more deeply. Yeah, Joy, what's up?
Can we go back to the map again? But still
Yeah, it should be right here.
Okay, I'm looking at that, and you just scroll over one of the points. And I think what I would find useful, and that's actually gonna get that, trying to dig down into it, is that it's, if this is based on OTN extracts, is using that unique detection ID. And not actually appearing there, the one that's invalid, because that you can search very quickly to find out which in your data set, what was invalid.
That is a great concept. Yeah, we should do that.
Cause and so from looking at this, so that one only has one tag ID, right?
Yeah.
But one of them that has 3 tag IDs, that's not necessarily saying that there are false detections for all those tags. It's just the number that were on there at the time, or?
Okay, yeah, here we go. Like so.
So.
Yeah.
Those transmitter IDs don't necessarily, all those may not have invalid detections, right? That's just saying what was there.
No, I think that's saying that those 4 had invalid detections at this station. There are the dates lined up there, the first and last dates by ID. So I think it's giving us the window there. But again, this is because I didn't investigate the output clearly enough to be able to answer that question. This is pretty new. I woke up one morning last month to find that Ian had completely overhauled the QC plotting step into this much nicer interactive version. But yeah, I did not do my due diligence in spinning myself up on some of the details here. So I think that those are, I think that's an interesting and useful thing to do, as you say, to use, to be able to hook this more completely into OTN data and display it in the tooltip. This is good. This is what I wanted. I wanted the researcher feedback. I wanted to know what you thought. This is very good.
I'm sure I spaced a little bit. Can you remind me what the difference is between invalid and likely invalid?
Oh, it's entirely to do with how many tests it passed or failed. So the way I've got it set up, I think, is if it passes fewer than a quarter of the tests, it's invalid. If it passes fewer than half, it's likely invalid. If it passes fewer than 75%, it's likely valid. And if it passes more than 75%, up to 100%, it's valid. I explained that in a weird way. In the code, it goes like the other way down the. You get it. It's a broken up by quarters, and it's a percentage value of how many of the tests you ran that it passed. Yeah, no problem. Further questions, further clarifications, further ideas if you're looking at this and thinking, well, I need this to do better. I want that. I don't know what maybe you don't sound like that, but
Can you remind me where I know we talked about velocity and what's reasonable and whatnot, but did I miss where you put in a number, or is it using a default number?
At this stage of the game, it's not. At this stage of the game, it's using a default number. I didn't mess with it too much because I was afraid. But I can tell you that it will all be in this line. That's where the user-facing variables will go. So this function call might get kind of long, depending. But whatever additional variables you want to pass into the system will go in the call to run QC. Again, trying to keep that tight and condensed, and condensed in the sense of not having too many functions to run. Yeah, that's where that will all go.
Distance travel of fine scale arrays where there's high overlap. Where, like I have arrays where the fish will be pinging on 3 receivers all at the same time, which would.
Yeah, that would completely throw off your velocity filter. No, I haven't done anything like that yet. I would like to. I'd love to. Can I have your data?
So it doesn't trigger.
Yeah, yeah, very, very shortly, my hope is that you'll be able to pass in a value to say, or like I said, you can control which QC tests you run.
Right.
So if you know that your fish are going to be pinging 2 or 3 receivers at once and your distance and velocity filters are going to be completely scrambled, yeah, you can tell Remora that, hey, just ignore those.
Could we also just write another line, like when I took the velocity function that was from Resonate and added code in there that basically said ignore or just make it pass if your receivers were within 2 kilometers of each other.
That
Mm.
does.
No, just make them valid.
Oh, that would be a useful thing to put in the velocity filter, yeah. Is somebody writing these down? These are such good ideas.
We're recording.
Oh, that's right. Yeah, okay, good. Yeah. Shannon gave me a look like I just asked her to storm Hill 800. Amazing. No, yeah, that's it's very exciting to get real-time researcher feedback because I want this to be super useful. I want this to be a useful tool in everybody's tool belt. Yeah, I was excited on Monday when we had that long discussion about quality control because working on Remora for so long, I did have a fear that I was going to demo it and the vibe was going to be a little bit like, oh, that's it. Like that's it. That's what all the fuss is about. But it does sound like there is a real appetite for QA and QC, and for being able to do that quickly, reliably, with a lot of versatility. So yeah, to get some real feedback finally from people who are hopefully going to end up using it. Very exciting. Do you want to see the grouper case study or do you want to get dinner early? It's up to you guys.
We can't go to the social until 6.
Let's see it.
Yeah, you want to see it? Okay, yeah, we've never met, right? Yeah. Can we take it? I don't need a quick break. But yeah, I mean, we're sort of going to take a quick break because this code takes a while to run, even longer. Let me get started on it actually. So this is another data set from Joy. This is Goliath groupers, like I said. There are useful things I think to think about in this. You're going to see a lot of the same stuff conceptually. One thing that is useful to point out, the get occurrence step here takes about 3 times as long to run because there are so many more detections in so many more occurrence instances for Goliath groupers relative to Atlantic sturgeon. Mike and I believe we were talking about the possibility of caching the results to make it a little smoother, a little quicker, so you don't have to generate them ad hoc every time. But also it is coming in as a data frame. So if you wanted to use write CSV to just output your occurrence CSV and have it and import it normally after that, that would also be well supported. While that code is running, does anybody have any further clarifications I can address? What are your questions? Yeah.
In the viewer, would you be able to change the color of the species distribution? Like white?
Yeah. In the viewer, No, I don't, not in the, like, once it's open, I don't think there's a way to do that. But more broadly, yeah, I think in the plot creation step, that would be totally possible. Yeah, not a bad idea. And there are no dumb questions. There are only things we haven't been taught. So, yeah. Yeah.
Yeah, how customizable is like the language that pops up? Want to take a screen grab of it and put in something, change any words around there, or is that like part of the way in the function?
At this stage of the game, it's part of plot QC. So it's building that tooltip dynamically within the function. But pursuant to Joy's question earlier, I'm going to be digging into that and tweaking it. So down the line, maybe there would be an opportunity to change what text goes in there, what information is displayed. Yeah, I don't know. That's something I would have to sit down and design. But yeah, I'm not against that. But at this stage of the game, yeah, it's pretty much what it is. What else? We've got 16% left before our grouper data is ready to go.
I just give a shout out, like, I'm super happy to see this come along, you know, this is gonna be really helpful when it comes to the visualizations and the data, but I think this is also really great, you know, we get this at the node level, it doesn't take away the art that has to happen afterwards, but especially for people that are new into the game, you know, I get emails, I'm like, oh my God, my vision to Canada will be the first time it's ever been documented in Canada, I'm like that.
Yeah, about that.
So having something like this, especially if we get them into the extracts, I think would just really help people get started.
Yeah, where is it? This variable here, roll up. That is the piece of the code that says, hey, return a detection extract that has the file or the QC information stuck on the end there. So that's, yeah, my hope is that we'll be able to use those going forward. The detection extracts with the Remora output. And also, I didn't even drill into my own development ambitions, because my idea for this is with the ability to turn tests on and off. This again sort of came up on Monday a little bit, this notion that, and again, here actually, when we were just talking about the velocity and distance filters in very, very, very fine scale arrays, not every QC test is applicable to every area or every species. But where I want to get us is to the point where somebody with rudimentary to intermediate R knowledge can pull down the Remora main branch, and following what I hope will end up being a pretty straightforward guide of, you know, here's a template, here's where you put the file, here's what you need to change in these, you know, 2 or 3 other files so that it gets picked up. Somebody will be able to write their own QC tests that are applicable to them and their study species and their study region, and then push that back up to the Remora repository as a branch. And then from there can be broader community discussions about, okay, what QC tests do we believe in? What ones do we not? Which ones do we want in main Remora? Which ones are useful? And so slowly we can build out a large library of QC tests that have been vetted by the community of researchers globally, so that instead of the vector up there where we've got where we've got 8 QC tests, maybe we can get 10 or 16 or 20 QC tests that you have the option of running, so that you can build your own suite of QC parameters that fits what you're studying and where you're studying it. And then when you write your paper and you cite it, you can say, hey, for quality control, we ran this and this and this and this and this from Remora. You can go to the GitHub. You can see it all laid out there. You can replicate and verify the results that we got. So yeah, I have some ambitions when it comes to this that I hope sound good. Because if I said all that and somebody was like, no, that's not what we need at all, I would have to change my plans. But yeah, nobody paused to yell at me and call me a fool. So I assume that you all want what I said. This code takes about 6 minutes to run. So if anybody's got any further comments or questions, or I can read a book out loud just to fill the space.
One of the, I like just totally thinking of this, is one of the ambitions to sort of, in this code, close the loop and using that roll of file, offer some capabilities to produce the new match detection data frame, removing what a user has gone through the invalid detections.
Yeah,
Effectively remove that line. Mechanism really, you gotta go through the fine comb, but really have the end product be a completed new match detection file for analysis with, version control of, here's my original file, here's what didn't pass, here's my new output file that I eventually ran on, or do you want to sort of think of that as a separate process each user does outside of Remora?
no, I do want the detection file that comes out of Remora to be to be useful in that way. But my thinking is to keep it in line with the GLaTOS pincock filter way of doing things, where you attach a column that says, hey, this passed, this didn't. And then the user has an opportunity to interpose themselves there and say, okay, I do want to filter out everything that failed the filter. Yeah. And that's part of the utility of having a few different scores of QC, because you can say, okay, I want to get rid of everything that's invalid, but not everything that's likely invalid, because I want to check those. So yeah, I don't think we'll get to the point where it'll be fully automatic to cut out everything that didn't pass the filter. But yeah, you're coming out of it with a detection extract file, so that can be read into R and mutated and modified with dplyr. All that filtering can happen fairly straightforwardly on top of that. So yeah, I that's where I'm at on that.
It's currently one of the files true to the format of the ingested match detection file with those new appended fields
Yeah,
of each. Okay.
that's the rolled up
Just makes-
file.
Slowly, step by step.
No, it's all good. That is the output of rollup is
Another topic.
I'm saving you.
But just not from John.
okay, good. Yeah, he's used up his goodwill. I got no more use for that guy. He and I'm not going to say that we're through, because I need the money. I need the job. I tell you. Further clarifications? Anything else that you'd like to know? Any ideas that you're having based on what you've seen?
Yeah, we disagree with an invalid because, like, let's say your receiver's really close and it's detected onto it once and fails all of the tests or whatever. How would you go about changing that before it spits out the last file? Could you do that?
I don't think there's a way to elegantly interpose the user at that step. I think you'd be getting to the point where you've got your rolled up file, and that's where you'd sort of be editing row by row, like, wait a minute, that's not really an invalid detection. I know that. I'm going to change that to this. Yeah. Every time there's a question that the answer is like, no, we can't do that yet, my brain steps off into design mode, and I'm thinking, but if I were to implement that, how would I do it? Yeah, I don't have a clear answer on that one yet. This is still running also. So this is also giving you an idea of when you're running on quite a large data set, you can, it can take a while. Okay, we're on 49 to 50. So we're getting there. I don't have to read the book. I do have the Wikisource page for Moby Dick open, because I was going to do a thing where, like, if nobody had any questions, I'd be like, well, all right, I'm going to read Moby Dick to fill the silence. And I would have done it too, but you all had really good questions and really good feedback, so I didn't need to do that. But I would have. It would have been hilarious. Or it would have been weird. I don't know. Like, you know, it was just an idea. Yeah, now now I want to get in on that QC summary.csv and just see what it's writing there. That's one of the tricky things about demoing this, is that there's a lot of stuff going on with it that I didn't write. This was built by folks down at IMOS, and I'm not saying that to throw them under the bus. They've written the pipeline has proven remarkably robust once I get it to the point of being able to ingest the data. But yeah, then there are these steps that sort of intuitively seem straightforward and easy and useful, but then when I actually am forced to stop and look at them and get out of my space of, oh yeah, the code runs, it's fine. I realize that actually I don't know what it's writing. So we've run all the grouper information. Here we go. So this is our grouper output. We've got the grouper home range, which you can see is up here in the Gulf. We got the little shards of home range down the South American coast, a little bit over in Africa. You'll note that there is this big, huge, perfectly circular hole in the home range. That's actually right in the middle of the Bermuda Triangle. I'm just messing with you. It's not. For one thing, the Bermuda Triangle is up here on the other side of the landmass. That's actually a data artifact. And I think it's really interesting and useful to talk about, because if I scooch over to the next, no, okay. Okay, I'm going to stop my screen share briefly because I have a different plot that I made. But just, yeah, everybody online, I'm going to stop screen sharing for a second, but remember that big weird hole right around Jamaica. Stop that share. I'm going to go back over to my plot. Yeah, okay, there we go. So share screen. Yeah, this is not a super nice, elegant plot. Here we go. Yeah. So I've just plotted the occurrence data from the grouper file. The orange dots are from GBIF, the blue ones are from OBIS. That's why Steve Formell is mutating those columns in the code to have the source there. I liked it, so I kept it, and it lets you do cool stuff like this where you plot your occurrences based on their source. But if we zoom in here, where's my zoom? I have to get my zoom toolbar out of the way so that I can go to the zoom button on my toolbar, which is not on the zoom toolbar. Look what they've done to us, man. Like, honestly. If we zoom in on this fairly grainy plot, you can see that the detection or the occurrence data, we have a nice, mostly continuous blob here and a fairly continuous blob here, but there's this break right on that landmass. And this sort of wide gulf right where our big mysterious empty circle is. So that's what I mean when I say it's a data artifact. We have got this little gap in the occurrence information. I'm going to go back to sharing my our studio screen so that I can go back to the viewer. Yeah, we have this little break in our occurrence data, and that creates this bizarre grouper zone of exclusion on our species home range where, yeah, if you didn't know that there's this process of assembling these alpha hulls that are minimally enclosing all of the occurrence points, you know, if you didn't sort of have a sense that that was happening, you might wonder, like, why grouper Chernobyl is there on the just off of Jamaica. But yeah, it's a data artifact. It's a weird result of not fully consistent data. There are 3 ways around it, and I'm going to present them to you in the order that I would most like you to use them. The reverse order, because the first one is you can ignore it and just say, well, I know that that is a mistake. I know where my fish are. I'm going to leave it and just get on with my life. Don't do that. That's bad. That's not helping. The other thing you can do, I will scooch over to the code. This create polygon function has a variety of additional parameters that you can pass to it. We're passing more through when we do the sturgeon creation part, fraction, parts count, buff, flip to coast. These are getting passed through from this level of the code, pardon me, to the volume model marine background function that creates the alpha hull. So they're documented quite well in the volume model and range builder documentation. Range builders get dynamic alpha hull function is what marine background runs on. So yeah, the underlying functions, those parameters are documented quite well. You can twiddle with them. You can change the amount of buffer. You can change the number of polygons you're willing to allow, disjunct polygons. And you can gradually try to dial it in and make a shapefile that's or a polygon rather, that's more representative of what you know the home range is, or at least what makes more sense. So that's the second possible solution. That one's fine. It's cool. If you've got the time to mess with the parameters, go ahead. The third thing you can do, and my recommended course of action, is publish your data to OBIS. These polygons are built from OBIS and GBIF data. So I think I have to grudgingly admit that John put it really well when we were talking about this before I left to come here. One of the novel things that we are doing in developing this code, developing the QC around these spatial shapes, is that we are creating the data set by which we perform quality control, by which we judge the quality of our detections. So if you take your data and you publish it to OBIS, that then gets used in creating the shape files that are going to help validate your data. So by pushing your data into OBIS, publishing your data into OBIS, and Angela, I think you can help people do that if they want to. If you aren't publishing your data to OBIS and you want to, you can talk to Angela. By publishing your data to OBIS, you are going to help fill in the blank spaces in the occurrence map or the occurrence data, and build better spatial objects, perform better QC, ultimately get better results, do better science, save the world. That's kind of what we're all here for when you get right down to it. So yeah, very exciting stuff. Publish your data to Obis. Remora will work better. We'll all be so much happier. It'll be great. Oh, we're coming up on 4:30. I really didn't think I was going to need all that time, but everybody had so many interesting things to say. This was a good time. I had a good time. Do y'all have a good time?
Yes.
All right, good. As long as everybody had fun, that's what's important. Also that now you know how to use Remora and that you're going to do it. Those were the two goals, that we have fun and that we all get excited for Remora. Does anybody have any closing comments? Anything else I can clear up before we I guess close? I don't know what happens after this.
All right, no one has anything else for Bruce?
Yeah, I asked the question that's gonna put you in bad mood. To close things out that way.
Nothing can put me in a bad mood. Go for it.
When, what's the timeline?
For what?
For getting this so we can put this in extract.
Oh, I don't know. You know, I'll have to look at the rolled up output and make sure that it's getting merged in properly. I mean, it's not going to be this push naturally because that's like starting as soon as we get back, and I don't want to. Yeah, that's not going to happen. I assume I'll get home and John will tell me when it needs to be done, and I'll be like, okay, that'll be fine. Does John want to chime in on that? Does he want to? John, you still there?
Repeat the question.
Oh, Joy wants to know what the timeline is on getting the Remora QC output into detection extracts.
We won't be able to hear every thought.
Well, that's okay. That's actually, that's better if we're being honest. No, he can put it in chat.
That we have a revamp that's happening now, it'll be the next iteration afterwards.
We have a revamp that's happening the next day. Yeah, okay. So there you go. I don't like to zero in on timelines because I'm usually unnecessarily bearish. I come from the corpo world of web design, so I tend to manage expectations.
You mentioned something else with the dog.
Yeah, missed that. It is therefore not in out. For a few bespoke data sets, we can create some for June, but the generic everyone gets this will happen a way down the road.